Hello, this is Dr. Hanaa Assil, and this is paper 1 of the International AS Chemistry, Cambridge. So let's take a look at the questions and discuss the answers. So the first question says the mass spectrum of a sample of neon is shown. So he gives me the mass spectrum. The relative abundance of each peak is written in brackets above it. What is the relative atomic mass of this sample of neon? Remember that we said the mass spectrum can be used for one of two things. Either I have a compound and it gives me the peaks for the different um, sections of the compound, or I have an element and that gives me the different abundance of each isotope. So in this case, we have an element, neon, and we have the different abundance for the different isotopes, and he wants the overall relative atomic mass. How do we do that? Remember, we look at the mass, which is the number on the x-axis, and we multiply it by the relative abundance. So I have a mass of 20 with a relative abundance of 100. So 20 times 100 plus the next one, 21 times 0.3 plus the next one, 22 times 8. Over what? Now, if the total comes up to 100, we say over 100. But here the total does not come up to 100. It is actually 108.3. So that is what I divide with. I divide with the total of all the abundance. So in this case, my answer is A. Then he says 2 grams of ammonium nitrate decomposes to give 0.9 grams of water and a single gas. What is the identity of the gas? So he's saying I have ammonium nitrate. It is breaking up to form something that he calls, for example, X plus water. And what we're looking for is what is the identity of X. Now, you should realize, first of all, that the total of the masses of reactants equals the total of the masses of products. So, if we're starting with 2 grams of ammonium nitrate and I got 0.9 grams of water, then the mass of X is the difference between them. So now I have the mass of X, 1.1 gram. Then I can get from the number of moles of ammonium nitrate. What is the number of moles of ammonium nitrate? It is mass over molecular mass. He gives me 2 grams. I calculate the molecular mass. You, of course, remember how to calculate molecular mass. The mass of nitrogen times how many plus the mass is the big number from the periodic table. I'm just reminding you. Plus the oxygens, I have 3 of them, so that would get you the MR. Divide 2 by that, that gives you the number of moles of ammonium nitrate. Good. Then I can get the MR of the product because the number of moles of ammonium nitrate is the same as the number of moles of X if you look at the equation. And that means I can get the molecular mass of X from the mass that we got, which is 1.1, over the number of moles. So that means that the mass of the compound, the MR of the compound that we're looking for is 44. So I look at the choices that I have. Which of these has an MR of 44? I find that it is C. Okay? Which of these elements has the highest fifth ionization energy? Okay, how do we know that? You should know that ionization energy, first of all, is the amount of energy needed to remove the outermost electron. Okay, if I want the highest fifth ionization energy, I'm looking for something in what? I'm looking for something in group 4. Why am I looking for something in group 4? Because something in group 4 would have 4 electrons in its outermost shell. So I remove the first electron, that's the first ionization energy. I remove the second electron, the third electron, the fourth electron, and then after that, the fifth electron is going inside an inner shell, which is closer to the nucleus, stronger attraction force to the nucleus. So the fifth ionization energy will be much higher than the others. So if I look at these choices, which of these are in group 4? Well, it is carbon and silicon. Now, which one are we going to use? If you look at the atomic structure of each of these, I want either carbon or silicon. The carbon has a smaller atom, so the electron that we're going to remove in the ionization energy is closer to the nucleus, stronger attraction force to the nucleus. It's actually the innermost shell, so that will be very hard to remove. So carbon would have higher fifth ionization energy than silicon, because the electron we're removing in silicon is further away from the nucleus, less attraction force, easier to remove. Okay, so my answer is A. Then he says the ion X2 plus has the same electronic configuration as the atom krypton. Okay, that means that X, if I remove 2 electrons, then it is like krypton. So what is the electronic configuration of X? Well, krypton has 36 electrons. So if I remove 2 electrons from X, it is 36. That means X had 38 electrons. Now, how are we going to distribute the electrons? Remember that we distribute them according to this arrangement. We say we're going to put into the 1s first, so it's 1s2, 2s2, 2p6, 3s2, 3p6. These are 18 electrons. Instead of writing them out, we write them as argon, because argon has 18. So 1s2, 2s2, 2p6, 3s2, 3p6, that's argon. And then I continue. I still have what? That was 18 electrons, so I still have 20 electrons. Now, I start from the 4s, that's 4s2, 3d, 10, 4p6, 5s2, that is my total number of electrons, and that is the same as B. Okay, of course, these are multiple choice questions. Paper 1 in the IAS is IAS Cambridge is a multiple choice paper. So you have a separate answer sheet where you shade the correct answer, whether A, B, C, or D. Okay, which type of interaction exists between water molecules and metal cations in an aqueous solution? Well, you should know that water, first of all, is polar. So it has dipole-dipole interactions as a water molecule. It has a negative end at the oxygen and a positive end at the hydrogen, since oxygen is more electronegative than hydrogen. So it can form hydrogen bonds with other molecules that have slightly negative and slightly positive. But here he's talking about positive and negative ions. So if I'm trying to dissolve something like sodium chloride, why does it dissolve in water? Some things dissolve in water because they can form hydrogen bonds. So if we say why ethanol, for example, dissolves in water, it is because it can form hydrogen bond with water. But the positive and negative ions of an ionic compound, they can dissolve in water because the water molecules surround the ions, so that if I'm talking about the cation, the positive ion, then the negative end of water will be attracted to the positive ion. The positive end of water will be attracted to the negative end of the negative ion, and that will separate the ions and will cause it to dissolve. So this kind of interaction is called ion dipole interaction. We have positive and negative ions with the dipoles of the water molecules. Okay, the next question says, which substance shows the greatest deviation from properties of an ideal gas under room conditions? First of all, what are the properties of an ideal gas? You should realize that the kinetic molecular theory says a gas is considered ideal if the collisions are elastic. That means when the particles collide with each other, they do not lose any energy. Attraction forces between molecules are negligible, so we're looking for something that does not have strong attraction forces between molecules, and the volume of molecules is negligible compared to the total volume. So if a gas has all of this, it is regarded as ideal. But most gases are not ideal. So he's saying which of these will show the greatest deviation. So which of these will not be ideal the most? Well, let's look at each one. Carbon dioxide has permanent dipoles, but they cancel each other because they're in opposite directions. So this molecule will just have London dispersion forces and dipole-dipole interactions between the molecules. Hydrogen is a nonpolar molecule, so it just has London dispersion or induced dipole-dipole interactions. The same with neon. But what about ammonia? Ammonia is a molecule that has the London dispersion forces, the permanent dipoles, and hydrogen bonding. Remember that when something has hydrogen bonding, these are the strongest intermolecular forces for simple molecular compounds. So ammonia will have hydrogen bonding, so ammonia would be the one that deviates most from ideal gases. Remember that if we draw the graph of PV versus pressure, ideal gases are straight lines. Any other gases would deviate from that. So ammonia is the one that has the greatest deviation from properties of ideal gas. Then he says, in order to determine the enthalpy of neutralization of a strong acid and a strong alkali, 25 centimeter cubed of 2 mole per decimeter cubed sodium hydroxide is added to 25 centimeter cubed of 2 mole per decimeter cubed hydrochloric acid, and the increase in temperature is 12 degrees Celsius. Now, in a second experiment, the same method is used, but 50 centimeter cubed of 2 mole per decimeter cubed sodium hydroxide is added to 50 centimeter cubed of 2 mole per decimeter cubed hydrochloric acid. So in this second experiment, he is doubling the volume of each. What is the increase in temperature in the second experiment? You should remember that delta H for a certain reaction is always the same. So here he's doing reaction between sodium hydroxide and hydrochloric acid. The delta H of that reaction will always be the same irrespective of the volumes that we're using. Also, it will always have the same increase in temperature irrespective of the volumes that we're using, because the increase, this is increase in temperature, this is difference between beginning and or initial and final temperatures. So it will always be the same. So without thinking, you should realize that the same temperature rise will happen. So it will still give 12 degrees Celsius. If you don't understand why, we can go through this with calculation. So if we take the first experiment, calculate Q for the first experiment. You know that Q is mc delta T. The mass is the total volume of solution. He used 25 of sodium hydroxide and 25 of hydrochloric acid. So the total mass of the solution is 50 times 4.18 times the temperature change. This gives me a certain Q. Now I can calculate delta H by Q over N. The Q that we just calculated, if you divide by 1,000, that gives it to you in kilojoules, over the number of moles. We said number of moles in this case where we have solutions. So concentration times volume. So 2 times the volume divided by 1,000. That gives me a certain delta H. And he says it is temperature increase, so the delta H is negative. Now, going to the second experiment, I can use this delta H. You should realize for any reaction, delta H is the same. So, using the same delta H, I can go back and find out what would be the delta T. So, if the number of moles, in this case, we have 50 centimeter cubed of 2 mole per decimeter cubed, so the number of moles is 0.1. Q is N times delta H, so I get Q. Then I use the Q to get delta T. It gives me the same value for delta T. So always remember that it will be the same increase in temperature. Which equation represents the enthalpy change of atomization of iodine? Now, you have to remember the definitions. What is enthalpy change of atomization? You should remember enthalpy change of atomization is the enthalpy change that takes place when 1 mole of gaseous atoms is formed. So first of all, I need to choose the equation that will give 1 mole of atoms. So B and D are wrong. And then he says, I need it to be formed from its element under standard conditions. What is the standard condition of iodine? The standard condition of iodine is a solid. So that means this is my answer in C. Zinc atoms can be oxidized to zinc 2+ by dichromate ions in acid solution. Chromium is reduced to chromium 3+. Which equation is correct? Do you know how to do ionic equations? Let's write each half equation and then add it up. So zinc goes to zinc 2+. That means zinc loses electrons and becomes zinc 2+. Now he's saying the dichromate ion is Cr2O7 with 2-, will change to Cr3+. Now, if we're starting with something that has an oxygen, then on the other end, after the arrow, I must have water. And since I have water, that means that now before the arrow, I must put H+. And then balance the equation. When we balance the equation, we get this for balancing, and that means that we have 6 electrons. So in order to add the two half equations, both of them must have the same number of electrons, and that means I can multiply that first equation by 3 in order to have the same number of electrons. Now I can add them up. When I add them up, I have this overall ionic equation. Which of the options do we have that is the same as this? That is number C. This question says the equation shows that hydrogen and iodine react to form an equilibrium mixture. The mixture containing equal amounts of hydrogen and iodine is made at temperature T1, and the composition of mixture is monitored, and he draws a graph for the mole fraction of iodine. So this is showing the change in concentration of iodine over time. Then he says the experiment is repeated at a lower temperature. Now let's see what will happen if I do this reversible reaction at a lower temperature. Well, the forward reaction is exo. How did I know that? The delta H is negative. So he has delta H is minus 9.6. That means the forward reaction is exothermic. So what will happen if I use a lower temperature? You should remember, a lower temperature will cause the reaction to go to the side that is exo. And that means that lowering the temperature, this reaction will go forward, or it will shift to the right. Now, when it goes forward, that means it will use up the I2 in the equation. So the I2 should decrease. So which of these options shows the I2 decreasing, the concentration of I2 decreasing? That is B. Do we understand that? Okay. Then he says the diagram shows the Boltzmann distribution energies of a reactant gas for a particular reaction. The activation energy is X. So X represents the activation energy. Now, which change to the diagram occurs if an effective catalyst is added at the same temperature? Remember, we have the Boltzmann distribution curve. We have to know what happens to it if I use a catalyst and what happens to it if I change the temperature. What happens to it if I add a catalyst? You should realize that when we add a catalyst, the activation energy will be a lower value. So instead of having the activation energy with no catalyst with a high energy, now the activation energy is lower, and that means I will have more molecules that have energy higher than activation energy. It is not more particles will possess higher values of it. Remember, particles will possess higher values of energy if you increase the temperature. The peak will move to the left or to the right if you change the temperature. But when you put a catalyst, all that happens is the value of the activation energy decreases. So now we have more molecules that will have effective collisions. Which element requires the least number of moles of oxygen for complete combustion of 1 mole of its atoms? Well, we want complete combustion of each one, and we want to know if I have 1 mole of each of this, it will need how many moles of oxygen. So let's go through this. Aluminium plus oxygen will give aluminium oxide. From the balanced equation, I can see that 4 moles react with 3 moles of oxygen. That means 1 mole of aluminium needs 0.75 mole of oxygen. Do the same for magnesium, phosphorus, and sodium to determine 1 mole of each of them needs how many moles of oxygen. Now he's saying which of these will need the least number of moles, so that is sodium. Okay? An element Y reacts according to the following sequence. What could be the element Y? Well, okay, what does he do to Y? He burns it in oxygen, so that should give me the oxide. He reacts it with HCl, so that dissolves in solution to give the chloride of the metal. Now he's adding sodium hydroxide. It gives him white precipitate soluble in excess. So which of these with sodium hydroxide will give white precipitate soluble in excess? You should realize that that is aluminum. In which list are all the 3 compounds soluble in water? Okay, let us review solubilities of group 2 compounds. We said we can have hydroxides. The hydroxide is a small ion. When both of them are small, so I have small cation with small anion, this has a very strong attraction force, and that means this will not dissociate easily. So magnesium hydroxide is less soluble than barium hydroxide. So barium is a big atom. The hydroxide will be soluble in water. If we're talking about carbonates, now carbonate is a big ion. The big with the big will be very strongly attracted, less ionization, less ability to break up. So barium carbonate is not soluble, while magnesium carbonate will be more soluble. If we're talking about sulfate, it is the same trend because sulfate is still a big ion. So the big with the big cation is insoluble. The big with the small cation is soluble. So let us take a look at this. He's saying in which of these are all 3 compounds soluble. So the choices we have in A, barium chloride is soluble because chloride is a small ion like hydroxide or even smaller. So barium chloride is soluble. What about calcium carbonate? No, calcium carbonate is not soluble because carbonate is a big ion, calcium is a big cation, so that does not dissolve in water. Magnesium hydroxide, this is a small ion with a small cation with a small anion, so that also will be less soluble. Now, in B, we have what? We have strontium carbonate. Strontium is a big cation, and we said carbonates with big cations going down the group, they are less soluble. So strontium carbonate is not soluble in water or less soluble. In C, we have barium chloride, barium hydroxide, and magnesium sulfate. All of these would be soluble. In D, all of these are less soluble or insoluble. So the one that has all of them soluble is C. Anhydrous magnesium nitrate decomposes when heated, giving a white solid and a mixture of 2 gases, X and Y. Now, you should realize, you should know that when I have magnesium nitrate and I heat it, what does it give me? It gives magnesium oxide, so that is the white solid, and it gives 2 gases, nitrogen dioxide and oxygen. So he's saying, why is oxygen? Now, that means that X is referring to the NO2. What is the ratio between the masses of the two gases released? So he wants the ratio between the two masses. So if we look at this equation, we will have 4 moles of NO2 and 1 mole of O2. I can use that to determine masses of these two gases because he wants ratios anyway. He doesn't want uh, a definite product. So the mass of the NO2 compared to the mass of oxygen, I can simplify this ratio and I will find that the mass of the NO2 would be 1, the ratio between them would be 1 to 0.174, and that makes my answer A. In a series of 9 experiments to test the reactivity of halogens, an aqueous solution of each halogen is added to an equal volume of an aqueous solution containing halide ions. So he has chlorine with sodium chloride, chlorine with sodium bromide, and so on. The 9 resulting mixtures are then shaken separately with an equal volume of hexane. The 9 tubes are left to stand so that the aqueous and organic solvent separate into layers. How many test tubes contain a purple upper hexane layer? Remember, which one would form a purple upper hexane layer if we have iodine? So we're looking for which of these reactions will have iodine in it. Okay, let's take a look at the chlorine with sodium chloride. Of course, chlorine with sodium chloride, that wouldn't give me any reaction at all. Chlorine with sodium bromide, well, that will give me bromine. That wouldn't give iodine. But chlorine with sodium iodide, remember we're looking for which solution will have iodine because that is the one that forms a purple upper hexane layer. So experiment 3, it has chlorine with sodium iodide. This will give sodium chloride plus iodine. So my solution will have iodine and it will form a purple color with the hexane layer. Now, the next reaction, we have bromine with sodium chloride. You should know that bromine with sodium chloride, there is no reaction because bromine does not displace chlorine. It's less reactive. Bromine with sodium bromide, no reaction. A halogen does not displace itself. Now, in experiment 6, what do we have? We have bromine with sodium iodide. That gives me sodium bromide plus iodine. So that would form a purple layer. Now, iodine with sodium chloride. Iodine with sodium chloride, no reaction because iodine is less reactive than chlorine. Iodine with sodium bromide, still no reaction. But when there is no reaction, what does that mean? When there is no reaction, that means that I have iodine in solution, sitting in the solution. So if I add hexane, it will still form a purple layer because the iodine is sitting there. It didn't react. So in 2 of them, the reaction formed iodine. In the last experiment, 7, 8, and 9, the iodine does not displace any of the other halides, so the iodine just sits in the solution. So I will still have a purple layer. So that means I have 5 of them giving a purple hexane layer. The next question says Z is a compound of sodium, chlorine, and oxygen. It contains 45.1% by mass of oxygen. Z is prepared by reacting sodium hydroxide with chlorine. Which row shows the conditions used for the reaction and the oxidation state of chlorine in Z? Well, sodium hydroxide with chlorine, you have 2 kinds of reactions. They can react on cold and they give these products, or with hot concentrated and they give this product. So the difference is for the cold it gives the NaClO, for the hot concentrated it gives NaClO3. Now, which one will give something that has 45.1% by mass of oxygen? So let's calculate the percent oxygen for each of these products. For NaClO, the percent oxygen is 21.5. For NaClO3, it is 45.1. So he's talking about the reaction with hot concentrated sodium hydroxide. In that case, the chlorine has an oxidation state of +5. So my answer is D. Which row is correct? The shape of ammonia molecule is what? And the shape of ammonium ion is what? So let's take a look. Ammonia molecule is something that has 3 bonds with a lone pair. So what kind of shape is this? You should remember that this is a pyramidal shape. So my answer is A or B. Then ammonium looks like this. Ammonium is something that has 4 bonds to be equally spaced with the least repulsion between bonding pair of electrons. It should be regular tetrahedral structure. Okay, will the bonds be sigma or pi or a mixture? You should remember that all of these are single bonds. Single bonds have only sigma bonds. Remember, a pi bond is present if I have a double bond or a triple bond. Single bonds are actually sigma. So my answer is A. The table describes 2 possible environmental consequences of adding too much fertilizer to the soil. Which row is correct? Remember, when we add too much fertilizer, the process that happens is called eutrophication. In eutrophication, the excess fertilizers are leached into the pond or the rivers that are nearby. This causes plants to grow on the rivers. So one of the effects of having too much fertilizer is I have increased plant growth in rivers. So my answer is B or D. Now, will the fertilizer cause photochemical smog? What is photochemical smog? Photochemical smog is the result of pollutants reacting with sunlight. So the sunlight affects some of the pollutants. So this doesn't have to do anything with fertilizer. So my answer is D. Hex-2-ene can be made by the reaction shown. Which statement about this reaction is correct? Okay, so first of all, what is happening here is the CH3, 3CO minus, is that behaving as a base or as an oxidizing agent? Well, this is something that accepts a proton, and we said if it accepts a proton, it is acting as a Bronsted-Lowry base. If he says the Ci bond breaks homolytically, no, it doesn't break. Do you remember homolytically means what? Homolytic means one electron goes to each of the atoms. No, the arrow going to I shows that both electrons are going to I. So this is not homolytic. This is heterolytic fission. Is this a hydrolysis reaction? No. Hydrolysis means it should involve water somewhere that we use to break the bonds. So my answer actually is A. Structure isomerism only should be considered when answering this question. Molecule X contains 3 double bonds. 1 mole of X is reacted with 3 moles of HBr. Of course, if I have an alkene and I react it with HBr, the bonds open up and add H and Br on the 2 carbons that have the double bond. So how many different products could be formed? Well, let's see. We're going to open up all the double bonds and put HBr instead of them. So you can have a diagram like this, or this, or this, or this. So you actually have 4 different products that can be formed. Then the next question says structural isomerism and stereoisomerism should be considered when answering this question. A colorless liquid exists as a mixture of 2 optical isomers. I'm going to remind you that optical isomers are ones that have chiral centers. A chiral center is a carbon that has 4 different groups attached to it. When heated with sodium hydroxide and ethanol, a mixture of only 2 alkenes is formed. What could be the colorless liquid? So remember that if we have C5H11Cl, well, A is this compound. he says they should exist with two optical isomers. Well, it cannot be A, because A will not have an optical isomer because the carbons are attached to two similar groups. So we have CH2CH3 on one end and CH2CH3 on the other. So this is not an optical isomer. Now, what about B? B, if I heat it with sodium hydroxide in ethanol, well, it will remove H and Cl. This is dehydrohalogenation. It will give a double bond on one side or the other, and the double bond in the middle can either have a cis or trans. So I have three different alkenes. He wants only two alkenes. So this is not my answer. C cannot be one of my answer also, because this is something that does not have optical isomer. There is no chiral center. For D, if we heat in alcoholic NaOH, well, we will have two alkenes. Each of them does not have a cis or trans isomer because they have similar groups on each carbon on either side of the double bond. So this would be my answer. So then he says, when 2-bromo-2-methyl-propane reacts with aqueous sodium hydroxide, an alcohol is formed. Which diagram describes the first step in the reaction? First of all, you can see that he's drawing this 2-bromo-2-methyl-propane, and you can see that it is a tertiary alkyl halide. Then you look at the direction of the arrows. What is happening with direction of the arrows? If you look at A, he says the bonding pair of electrons will go to the carbon. This is not right. The bonding pair of electrons goes to the slightly negative one. So it should go to the Br, not to the carbon. And then you should realize that a tertiary alkyl halide does what we call SN1. So the Br separates first to form a carbocation, because this is a tertiary carbocation that is very stable. So we don't have, in C, we have the direction of the arrow is wrong. In D, he's saying it will be an SN2. No, for the tertiary, it is usually an SN1. So my answer is B. When an organic compound Q is treated with phosphorus pentachloride, fumes of hydrogen chloride are evolved. Okay, let's remind ourselves. Which compounds react with phosphorus pentachloride? Well, you should realize an alcohol would react with PCl5 to give white fumes. Also, an acid would react with PCl5 to form HCl fumes or white fumes. So Q is either an alcohol or an acid. And then he says, so A is not right. So when Q is warmed with acidified aqueous potassium dichromate, the solution turns green. You should remember that potassium dichromate is an oxidizing agent. The oxidizing agent changes the alcohol into acid. So, or aldehyde to acid. But the problem with A is that if it is an aldehyde, it does not react with PCl5. It would react with potassium dichromate because the aldehyde can be oxidized to acid, but it will not react with PCl5, so it's not A. Now, B is an acid, but the acid does not react with potassium dichromate. It cannot be further oxidized, so it's not B. What about C? C is something that has a secondary alcohol, so that would react with PCl5 to give white fumes, and it would react with potassium dichromate to give a ketone. The last one here is a tertiary alcohol. You should remember that tertiary alcohols cannot be oxidized, so they will not react with potassium dichromate, and that means my answer is C. Alcohol Y gives a yellow precipitate with alkaline aqueous iodine. Now, what is this test? Do you remember this? What gives a yellow precipitate with alkaline aqueous iodine? This reaction is the one where we have a secondary alcohol that has a CH3 next to it. So it's actually an alcohol that has the OH on the second carbon. When we react this with alkaline aqueous iodine, so iodine in sodium hydroxide, that eventually gives me a triiodomethane, and that forms a yellow precipitate. So if he says that Y does this reaction, that means Y must have this group, CH3CH with an OH on it. Then he says it can be oxidized to give a mixture of products, including substance Z, and substance Z gives a red-brown precipitate with phthalings. Again, what substance gives a red-brown precipitate with phthaling? Remember that phthaling solution is a test for aldehydes. So that means that I want something. If it is oxidized, it can give an aldehyde. So let's take a look. Which of these is possible? So A, this is A. If you draw it, you should draw it, or maybe realize that this is the compound that he says it's A. So if I look at it, it has this group, which is the CH3CHOH, so it will form a yellow precipitate with alkaline aqueous iodine. It also has a primary alcohol, and we said primary alcohols, when you oxidize it, it could give aldehydes. So actually this should be my answer. Let's look at the others. B has a tertiary OH. It doesn't have that group that forms yellow precipitate with alkaline aqueous iodine. It has a primary alcohol, yes, but it will not give a yellow precipitate with the alkaline aqueous iodine. C, it will not, D will not, and that means my answer is A. This compound reacts with hydrogen cyanide to form an organic product called a cyanohydrin. Which statement is correct? Okay, this compound that we have is actually a ketone, and the ketone, when it reacts with HCN, the C double bond O opens up, and we put a CN on the carbon and a hydrogen on the oxygen. So this is what we call a cyanohydrin. So statement A says the cyanohydrin product has one chiral center. Well, does this have a chiral center? Remember, we said a chiral center is bonded to 4 different groups. This one has CH2, CH3 on both sides of the carbons. So this does not have one chiral center. Then the other statement says the cyanohydrin product is formed by electrophilic addition. No, you should realize that this kind of reaction is nucleophilic addition, where the cyanide attacks the slightly positive carbon and the electrons from the double bond go to the O minus. This is nucleophilic addition. The cyanohydrin product is formed via an intermediate that contains COH. No, our intermediate has CCN. The formation of cyanohydrin product requires the use of a cyanide ion as catalyst. Well, yes, that is actually correct. So that is my answer. Reduction of compound R with lithium aluminium hydride gives the compound 4-methyl pentane 2,3-diol. What could be the identity of R? Remember, lithium aluminium hydride is a reducing agent. So it reduces the ketone to alcohols. So which of these will give this compound? Well, let's look at what compound this is. 4-methyl pentane 2,3-diol. So this is the compound that you will have. Now, what compound, when it is reduced with lithium aluminum hydride, it will form this? Well, you can see that it is A. Okay. Citric acid is found in lemon juice. Which volume of 0.4 mole per decimeter cubed sodium hydroxide is required to neutralize a solution containing 0.005 mole of citric acid? Well, what is citric acid? This is the kind of structure. If you draw it out, this is what we call citric acid. Now, acid reacts with sodium hydroxide. Remember that acid reacts with base, so it reacts with sodium hydroxide. Each of the hydrogens from the acid will have to be replaced by sodium, and that means that 1 mole of citric acid needs 3 moles of sodium hydroxide. So the number of moles of sodium hydroxide I would need for this question is 3 times the number of moles that he has. And that means that if the number of moles is concentration times volume, how do we get volume? Volume is number of moles over concentration. So that means that the volume I need is 37.5 centimeter cubed. Are you able to do all of this? Some of them are easy, some of them need a little bit of thinking. Okay, the structural formula of an ester is this. The ester is boiled with hydrochloric acid. Which two products are formed? Remember, the ester was originally formed from alcohol and acid. So when you boil it with hydrochloric acid, this is called hydrolysis. It breaks up into the original acid and the alcohol. So if we draw this and take a look at what happens when you do hydrolysis of this ester, it will give this acid and this alcohol. So the acid is the one with 4 carbons, so that is butanoic acid, and the alcohol is what? Well, this would be called propane 2-ol because the OH is on carbon number 2. The infrared spectra of 3 organic compounds are shown. So he gives me 3 spectra and he says what could be the 3 compounds. Well, let's take a look at each one. So this is the first spectrum. Now, what are the choices that I have? I have this, acid or ketone or alcohol. Well, looking at this spectrum, we said the most important part that you look at is the part at around 1700 and the part at around 3000 and something. Can you see that? Now, at 1700, do I have a peak or not? Yes, I do. Now, the peak at the 1700 is due to C double bond O. But do I have a peak at the 3000 and something? No, I should have a large peak if I have an OH. So this means I have something that has double bond O but no OH, and that means it has to be a ketone. So my choices are B or C. Can you see that? Okay, so that's spectrum 1. Spectrum 2, let's take a look at spectrum 2. What do we have? We have a peak at 1700 and a peak at 3000. That means that I have an acid. So my choice should be propanoic acid. Spectrum 3, what do I have in spectrum 3? I have the peak for the OH at 3000 and something, but there is no peak for the C double bond O, and that means I have an alcohol. So my choice is B. The second section of paper 1 in the Cambridge has choices. He gives you 3 statements and you decide which ones are correct and which ones are wrong. Now, if all 3 of them are right, then your answer is A. If only statement 1 and statement 2 are right, then your choice is B. If only statement 2 and 3 are correct, you choose C. If only statement 1 is correct, you choose D. And this is written in your paper, so it should be easy to do. So for the first type of this question, he says, which changes can be used to measure the rates of chemical reactions? How do we measure rate? Well, decrease in concentration of reactant. Yes, I can use that to measure the rate. If we're using up a certain reactant, then I can measure the concentration of this reactant and use it to measure the rate. The rate of appearance of a product, yes, we usually say we measure the volume of the gas formed, for example. The increase in the total volume of gas per unit time at constant pressure, well, yes, if we're doing gases, all of them are gases, I can measure the increase in total volume. So actually, all of these statements are correct, and that means my answer is A. The next question says iron reacts with steam to produce hydrogen and an oxide of iron. A system containing all 4 substances is at equilibrium. Which changes will decrease the mass of iron present at equilibrium? You should realize that decrease the mass of iron means which one will cause the reaction to go forward, because when this reaction goes forward, then it uses up the iron in the reactant, so the mass of the iron decreases. So basically we're asking which of these will cause the reaction to go forward. Okay, the first choice is addition of steam at constant pressure. Yes, actually, if I add any of the reactants, the reaction goes forward, and that means that the ion will be used. So that is correct. Increase in overall pressure. Remember, in general, increasing the pressure will cause the reaction to go to the side with less molecules. But that applies to what? It applies only if the reaction has gases. This reaction has solids. So actually, this statement is not one of my answers. Addition of an effective catalyst. What happens if I add a catalyst to a reversible reaction? We said it increases the rate of both forward and backward, but it does not affect the point of equilibrium. So it will not cause the reaction to go forward or backward. So only statement 1 is correct, and that means my answer is D. Ethylene glycol is used as a de-icer. It allows ice to melt at temperatures below zero. Which statements are correct? Well, let's look. What is ethylene glycol? This is ethylene glycol. He already draws it for you, but drawing it out would make it more uh, easier. Then you should realize that this means that I have permanent dipoles. I have oxygen attached to hydrogen, and that means that this compound can form hydrogen bonds with itself, or it can form hydrogen bonds with water. So the first statement says ethylene glycol disrupts the extensive network of hydrogen bonds in ice. Well, this is ice. Remember, ice means the water molecules come nearer to each other, they form hydrogen bonds, and they're stuck in this kind of structure. And we said this is why ice has lower density than water, which normally is not applicable to other solids. Most solids are more dense than their liquid form, except for ice. So yes, the ethylene glycol can form hydrogen bonds with this structure, so it would disrupt the extensive network of hydrogen bonds. Okay, the next statement says ethylene glycol forms hydrogen bonds with other ethylene glycol. Yes, it can form hydrogen bonding because it has oxygen, which is electronegative, attached to a hydrogen atom. Ethylene glycol molecules will dissolve in water. Yes, anything that can form hydrogen bond with water will dissolve in it. So all three are correct. So my answer is A. Which molecules contain at least one unpaired electron? Well, let's draw the dot and cross for each one. So NO, yes, it contains one unpaired electron. NO2, yes, the nitrogen has one unpaired electron. Ammonia, no, it doesn't. Ammonia has a lone pair of electrons, not one unpaired electron. So 1 and 2 are correct, so my answer is B. Which elements form a chloride in which both covalent and coordinate bondings are present? So I want a chloride that has both covalent and coordinate or dative bonding. Remember, when aluminium forms a chloride, this is the kind of structure that you have. So the aluminium forms covalent bonds with 3 of the chlorines, and it forms a dative bond with a chlorine from a next molecule. So we say it dimerizes. So yes, aluminium will have both, but silicon, when it forms chloride, it's just covalent. Magnesium, when it forms a chloride, it's only ionic. So only A is correct. So my answer is D. Which statements about calcium oxide are correct? The first statement says it can be reduced by heating with magnesium. Well, let's look at the reactivity series. Can I react calcium oxide with magnesium? Will magnesium displace the calcium? No, because calcium is more reactive than magnesium. It cannot be displaced by it. So this is not right. It is produced when calcium nitrate is heated. Well, yes, when we heat calcium nitrate, it gives calcium oxide, nitrogen dioxide, and oxygen. So this is correct. It reacts with cold water. Well, yes, calcium oxide is a base. It reacts when it dissolves in water. It forms calcium hydroxide. So 2 and 3 are correct. So my answer is C. A diketo acid is a compound with two ketone groups and one carboxylic acid group. Which statements about the reactions of these compounds are correct? So the first statement says, when reacted with excess hydrogen and nickel, they produce the same compound. Well, what does hydrogen and nickel catalyst do? It removes the double bond. It reduces the double bond. So the double bonds are removed and we have hydrogens instead of them. You can see that the two molecules, if I remove the double bond, they will form the same compound. The next statement says an excess of hot concentrated acidified potassium permanganate reacts with both of them to form different diketo acids. Well, what does hot concentrated acidified potassium manganate do? It breaks up the double bonds. So if I break up the double bonds, then each of these will give me different acids or diketo acids. So that statement 2 is correct. Now, the reactions of limonene and terpinolene with an excess of bromine. Okay, excess of bromine means I'm going to put bromine into each of these double bonds, open the double bond and put Br on the carbons. Now he's saying this will give positional isomers with the same number of chiral atoms. Well, which of these are chiral? In limonene, the chiral carbons are only 3 of them. That fourth one will not make a chiral carbon. But in the other compound, terpinolene, this gives 4 chiral. So this statement is wrong. So 1 and 2 are correct. So my answer is B. One molecule of dodecane is cracked producing 3 molecules, X, Y, and Z. X is a straight chain alkane. Now, Y and Z are straight chain alkenes with different MR, so they have to be different alkenes. So he's saying X should be an alkane, Y and Z should be different alkenes. So let us take a look at this. If Y and Z are butene and ethene respectively, X will be hexane. Well, let's take a look. The dodecane is C12. So if I'm going to cut it so that, or break it up or crack it, so that it gives butene, which is C4H8, and ethene, C2H4, then I'm left with C6H14, that is hexane, so that is correct. If X is butane, Y and Z should show cis trans. Well, let's see. If I have dodecane and it breaks up to form butane, so X is butane, C4H10, then what is Y and Z? He's saying Y and Z should both show cis and trans. Well, the only options I have are, if it's a C6, it's C2, C5, C3. Remember, they have to be different alkenes. So I cannot say, for example, C4H4, H10 for both of them, or C4H8 for both of them. So in this case, we have C6H12 plus C2H4. C6H12 can have cis-trans isomerism, but C2H4 or C3H6 cannot have cis-trans isomerism. So actually that statement is wrong. Now, X could be octane. Well, X could be octane. If X is octane, that will mean that the other two have to be C2H4 and he wants them different. So they cannot be both C2H4. So that one also is wrong, and that means only one is correct, and my answer is D. Which statements about chlorofluoroalkanes are correct? What are chlorofluoroalkanes? They are things that have fluorine, chlorine, bromine. They are alkanes that have fluorine, chlorine, bromine. Both the CCl and the CF bonds are readily dissociated by UV light. Okay, if we look at this, which bonds will be readily broken? Remember that the CF bond is a very strong bond. So the last bond that will probably break is the CF. CCl could be easily broken. CBr could be broken. But if he says CF is readily dissociated, that is wrong. They have caused ozone depletion. Yes, when we talked about chloroalkanes, Yes, they will affect the ozone layer because they break up the ozone layer. So that statement is correct. They are chemically inert. Yes, they are not easily broken. They need UV light to be broken. So that statement would be correct. And we said that would make my answer C. The last question, which reactions of propanol have water as one of the products? Okay, he wants to pass propanol over hot aluminum oxide. When you have propanol with hot aluminum oxide, what happens? It is a dehydration. You remove H and OH, and one of my products is water, so that is correct. Mixing propanol with ethanoic acid and a few drops of concentrated sulfuric acid. Alcohol plus acid gives ester plus water, so that is correct. Warming propanol with HBr. If I heat propanol with HBr, what happens? The OH is removed and replaced with a Br, and that means my other product is water. So all of them are correct, and my answer is A. I hope you found this useful. Thank you for listening.